So today I have a quick update on the ongoing machine vision project that's been going on here. Normally I would be covering something directly hardware related such as electronics, robotics, IoT, or a communication system, but to switch things up a bit, I have a couple of raw clips taken from a few field tests in object detection. This is mostly trying to detect vehicles while I'm driving around, and you could say this is a fairly early trial run with not a whole lot of cherry picking. Translation, you're going to see a lot of false detections and other minor glitches, which is sort of the whole point of these tests in the first place. And going forward, it should be interesting, to say the least, to see how these detections improve over time. Most of what I'm showing today was post-processed after being captured using dash cameras. After each drive, I retrieve the footage from the camera and then use a computer vision library called OpenCV to detect any vehicles that were present. OpenCV also runs on the Raspberry Pi thanks to Python, and in fact, if you've already seen my videos on setting up the Raspberry Pi operating system, setting up the Raspberry Pi camera, and testing Python 3 in the Raspberry Pi operating system, then you're already at the point where you could go ahead and install OpenCV 4.4.0 anyway. I've already tested doing this multiple times using the Raspberry Pi 3B Plus, and it may be time for a fourth tutorial on how to install it on the more powerful Raspberry Pi 4. Fair note, you can install it either using the pip package installer or by compiling OpenCV from source. Doing it from source is the more powerful option, but if you've done it before, then you probably know where I'm going with this. The process is very user-unfriendly, and even if you're used to a Linux environment and the terminal, it's easy to make a mistake or skip a step that can set you back considerably. And really, even if everything goes perfectly fine, the compilation takes about 2 to 4 hours, depending on the model of Raspberry Pi you're using. You can start doing your own detections in real time, and because they can wind up looking about the same, you can see my text annotations in every video clip, just so we're clear on what was generated in real time, and what was the result of having a desktop computer post-processing everything. So how are things going so far? I mentioned that the Raspberry Pi 4 was the more powerful option available currently. This is the focus of the ongoing project, and even though I'm not driving around with Raspberry Pis in my car, that could soon change thanks to a few hardware upgrades. The main processor is a Raspberry Pi 4, the case is grade 1018 carbon steel, something I had custom machined, and the control board is also custom. The detection is done using OpenCV's hard cascade classifier, which is probably one of the more basic classifiers in the library. It sweeps through every frame of video independently, searching for features that match the front or back of a vehicle. So far, the dataset shown here is pre-trained, which is partially why you're seeing it erroneously marking parts of my own vehicle. This model of camera, which is not the Raspberry Pi camera, also has a slight fisheye effect to it, so everything you see is closer than it actually looks. Because of this, the accuracy does take a hit, and the closest vehicle needs to be fairly close in order to be detected. But for a generic dataset, it's not off to a bad start. Besides the hard cascade classifier, there are plenty of other algorithms and methods I could use to replace this one or validate the detections, but that's something I'll have to cover on a future date. If you found this useful, be sure to like and share the video. This lets me know what people are interested in, and it helps the channel in general. Also consider joining the Unboxing Tomorrow Patreon page, where we have a monthly poll and lessons learned on technical builds like this one. The poll for August 2020 wants to know if you use anti-static countermeasures, like the ones that were featured in a recent video. Stay posted for more electronic projects, and as always, have a great day.